Today I'm going to look at the Substance Designer 6 FX node. Let's see. File, New Substance. We'll accept the default there. Now I'm going to click in this window here and I'm going to hit the space bar and ask for an FX map. Now the FX map is an interesting node that lets you generate some textures. So what we want to do is we want to go inside of it. So I'm going to say Control E or Command E, or alternatively I could hit the edit button over here. Maybe I'll just do that. Now we're inside. Now if you look, the first thing that it gives you is this thing called a quadrant. A couple of things that are interesting about that. One is that you can build up these quadrants and subdivide space into smaller and smaller partitions. And the other is that it kind of gives you the idea that maybe there's something important about the number 4 because everything is presented in terms of quadrants. But really what it's doing is it's subdividing space lengthwise in half and widthwise in half. So it's really octaves that it's doing. And it's very helpful for generating 1 over f noise, which is basically as the frequency increases, the amplitude decreases. So you have, hills, and then you have half-sized, more frequent, twice as frequent hills, but half the size on top of those, and so on and so on and so on until you get a very rough, kind of complex, interesting terrain. One of the things that I want to point out right off the bat is that this thing has a few of these things. It's got what's called an input up here, and it's got output 0, output 1, output 2, and output 3. I have no idea why they call those things outputs. These things are inputs. This is an output. So that's one of the reasons why I think this can be confusing. Let's see what the quadrant does. First thing that is, if you double click on it, you get to see some of these parameters. I'm not going to go into detail about what those all are until we get kind of a higher level understanding of what's going on here. This quadrant does really 3 things. One is it can generate a pattern from this list. The other is it can accept a pattern from the outside world passed into it in the form of an image. And the third thing it can do is it can take whatever kind of bubbles up from below into these inputs, which they call outputs, and it can subdivide them and put them in the appropriate quadrant. So let's see what that exactly means. Here's a quadrant, and notice that it's orange. That means that it's the output. So if I right-click and I say set as root, I would be able to do that if it weren't already the root. So let's get a few more quadrants. Here's one here. I could get it that way, or I can hit the space bar here and ask for a quadrant that way. So there's a quadrant. Here's another quadrant. Notice it came because the first one was selected. It comes already connected like that. This is useful for certain things, but it's also what is confusing when you first get started with this. So I'm gonna take that away. And I'm also going to click off of that quadrant so that when I ask for a new one, it doesn't come pre-installed with another quadrant below it. So here we go. Now we have 4 quadrants and this one that's supposedly root up above. Let's look at the root. Pattern, no pattern. Let's look at this one. Pattern, no pattern. They're all going to say no pattern. So let's make this one here. Let's temporarily right-click, set that as root so we can see what the deal is. And let's set the pattern to a disk. Let's right-click, set that as root so we can see, by the way, set as root. I sort of took for granted that that was appearing over here, but it's over here. So you can see that the disk is there. What I did was I just enabled alpha on this disk, and in fact we are working on color images rather than grayscale, but it doesn't really matter. So let's see, right click on this one, set it as root. Let's make this pattern be a bell. Let's right click on this one, set it as root so we can see it. If there's another way to easily see it, I'd like to hear it in the comments, but until then, this is how I do it. I'm just learning this myself. But I'm noticing that in the material that I've been going over, that there's certain aspects that are confusing about how it's been explained. So I think I might have a better way of explaining. I think I might have a better way of explaining it. There's pyramid. Right click, set as root, and let's set this one as waves. Okay, there we go. So now we have these things and they're all generating patterns. So the first thing is, let's set this guy to root up here so we can see what he produces. So he's got no pattern going on, so he's producing nothing of his own. Now, if I connect this to that guy's input from below, you can see that disk, I'm going to right click here again. Right click, set as root. You can see it's a big disk. It's a big white disk. And when I set this as root, you can see it drops down to gray. I'm not sure if that's a bug or if they are intentionally lowering the amplitude of the signal with every octave or what exactly is going on there, but it seems to drop down half gray right away and settle in at that level of gray, or maybe get darker as the octaves build up. I'm not quite sure which, but at any rate, doesn't really affect us too much at this point. So right click here, set as root. That's this blurry thing. Put that up there. Right click here, set as root. Now you can see that this guy goes to this quadrant. This guy goes to this quadrant. Let's connect this and let's connect this. So now you see that these four things all connect to something, all connect to different regions of the quadrant up here. You can optionally, and this is one of the confusing parts, you can optionally up here where I double clicked on this root where it says no pattern, you can optionally put another shape on top of that, which is generated by the node that you're actually on at that moment. I'm going to leave that to no pattern so that it's only receiving information from its children. So now, let's say that you want to talk about this guy here. So you could say set as root. This is the disk. Now I'm going to click off of everything so I can get a quadrant. Here's a quadrant, and Control C, Control V, Control V, Control V. So here are four more, and really fast, set as root. Let's just make this, I don't know, bell. Right click, set as root. We'll make this brick, whatever that is. Right click, set as root. And we'll make this capsule. Right click, set as root. And we'll make this crescent. Okay, fine. Now we right click, set this as root. This is generating a circle. So let's say instead of generating a circle, let's leave it generating a circle, and then we'll pass this up into it. We'll pass this up into it. We'll pass this up into it, and we'll pass this crescent up into it. Now let's go back to this guy and turn his pattern from disk to no pattern. So he's not making something of his own. He's just inheriting from his children. So if you now look at so here's the deal. These four things are going to the quadrants of this guy, but this guy maps to only one quadrant of that guy. So if I make this guy the root, you can see that I've accumulated some patterns here, and these are all kind of like that. Now you can also do things like this, for example. You could start to go like that, or you could go like that. So you start to see, how these sorts of things accumulate patterns in that way. So one of the reasons why I think, one of the things that's kind of interesting is that you can make a quadrant, and then once it's there, you can do this, and you can chain it a number of times, and what you're doing is you're subdividing it into 4, into 4, into 4, and it's tempting to tell everybody that you're starting at the top and you're working your way down, but you're really not. You're starting at the bottom and you're working your way up. And one of the reasons why this thing is built in this particular way is because this guy would have 4 children. They all happen to be identical, but it would have 4 children. And then each of these 4 children would have 4 children. Now you're looking at 16. Then each of those 16 children would have 4 children, and each of those would have 4 children, and so on and so on. So very quickly, a chain this long, if you made every child explicit, would be very wide and very difficult to deal with. So that's one of the reasons why this is kind of convenient, particularly when the children are going to be the same. One of the things that you might think of, well, I really don't want the children to be the same. I want there to be variation among them. What good is it to have a bunch of, same things all the way down? Well, one of the things that you can do is you can make the parameters of each of the children, of each of the quadrants. Each of these parameters can be driven by a function. And even though the function may be the same from node to node all the way up the chain, if they use, for example, random numbers, then it gets called uniquely every time. And so you very quickly build up randomized noise where you've got a simple chain, but there's a lot of randomness built into it. And so that really makes kind of a richness. Let's see. So that's the first thing, is that it goes up like this. Now, maybe we'll take a quick look at what's next. We have iteration, we have quadrants, and we have switches. Let's take a quick look at switches. So if I say quadrant, and I go to the quadrant, and I leave it at no pattern, and then Control-C, click off of it so it doesn't auto-connect, Control-V, Control-V. So now I have, let's say, this guy is a pattern which is, I don't know, let's make it a disk. And let's make this guy be a capsule. So that they're fairly different looking, because just in terms of size, they're fairly different looking. Now, one of the things that I want to do, notice I have nothing as root now, so you're not seeing anything over here. If I click on this and say set as root, right click, nothing happens. Right click, set as root, you see there's the disk. Right click, set as root, there's the capsule. Maybe I'll make the capsule something a little bit more different than a disk. Maybe, pyramid, where's that? There it is. Okay, that's good. So now what we want to do is we want to switch between these two things. So I come over here and I click off of everything. I ask for a switch. There's a switch. And now I put this into one side of the switch, and this is into the other side of the switch. These are inputs. They go up into the bottom. They bubble up from the bottom. They go into the switch, and then the switch can pass along something in the switch's output. Again, even that's called an input, but again, it's really not good, I don't think, to think of it in that way. And that could pass along to a quadrant, or this switch itself could be you could be done at that point. So let's say you're done at that point, and we'll set it as root. So if we look inside the switch, there's a button here that says left, right, and you can see that it's clicking back and forth between the pyramid and the disk, left, right. So one of the things that we might want to do is make it so that this thing is chosen through some sort of statistics. So let's go over to there, and we go to where the button is. It's right, and there's a little kind of a thing that looks like a function curve, and we can say empty function. We do that. Now we click on this bright version of the thing, and it says edit. We go inside. Now we're ready to edit our function. So what we're going to do is, let's see, I'm going to click here, and I'm going to hit the space bar, and I'm going to type in random, because I want a random number. And I want my random number to be generated between 0 and 1. So I'm going to hit the space bar again, and I'm going to ask for a float. And I'm going to put that over there, and I'm going to connect that directly and double click on this. And I'm going to pull this slider up. You can see the numbers changing. Pull this slider up to 1. Now I have a floating point number that goes into this random number generator. Now what this does is it generates a random number between 0 and whatever that is. So it's going to be a random number between 0 and 1. So the next thing I want to do is I want to compare that to another number. So let's see. We say greater than, and there's a greater or equal, and there's a greater than, and the difference is, in our case, insignificant because it's either slightly better than 0.5, like 0.500001, or it's 0.5. So it doesn't matter. I'm going to say greater. So let's see. What does this do? The greater function returns true if first entry is greater than the second entry. So the first entry is a random number. That goes there. And the second entry, click this, Control C, click off of it, Control V. The second number is going to be something that we set as a percentage. So I'm going to click here and I'm going to make that be 0.5. Or there, or just whatever that is, 0.495. So now, if this is true, then we want to return true, or if it's false, we want to return false, but either way, it's going to be the switch value, which is going to determine whether we see a disk in the top or whatever that other thing was. So I'm going to right-click on this. I'm going to say Set as Output Node. Now, we're ready to go back to the FX map. So here's the FX map, and you can see that the switch is set to... we're seeing a disk. So here, this little guy here, let's say that I Control C, put him aside, and then Control V, Control V, Control V. Now, if I take this and make him the set as root, and we put this up into that guy, there's a pyramid. We put this up into that guy. There's a circle. We put this up into that guy. There's a circle. And we put this up into that guy. There's a pyramid. So now we have no idea what, in fact, that's going to do. So if we were to, let's see, what would be good? If we were to take this whole thing and copy it, just for the sake of argument, you can see what I mean by it gets wide fast. So there's that. Now, let's say that we have a quadrant here. So the first thing is we want this guy to go to there. We want to make this the outset as root. So we want that guy to go to there. So there's this pattern. We want this guy to go to there. We want, bring this over to make it a little easier. We want this guy to go up into there. And we want that guy to go into there. So now, a couple of things. One is that if we go back into, let's see, this guy here, and we go into the switch. Well, we could set it up so that the variable would change. But we could do something like take this chain and then watch this. This is kind of what the value of those. Now, notice they tend to want to always force you to make it come from below. But if you ask for a quadrant and you connect now, this is going to be the same thing in all 4 quadrants. and I'm going to set that as root. But notice it's not the same thing in all 4 quadrants because the random numbers are being called uniquely each time. So if I ask for another quadrant and I come in here and set this as root, notice I'm working my way up, and this seems to make logical sense. I mean, you're putting that up there. There's another quadrant coming in. There's another quadrant coming in. There's another quadrant coming in. Notice they're not all different. And then here's another, notice they're not all the same. And then here's another quadrant, finally, set as root. There. I think there's a shortcut for connecting all of these things at the same time. But you can see now that there's a variation here that you wouldn't, that's completely random. So that's kind of an exploration of a little bit kind of understanding the way that the logic flows in these graphs. It flows upward from below, not the other way around. Okay, now let's take a quick look at references. So FX node, FX map, and select it, Control E, go inside. Now let's say, click off that, I want a quadrant, and let's connect that like that. And let's just for the moment make this the root so we can see what's doing in there. So I'm going to take a pattern, make it a square pattern, and width is going to be pretty skinny. And right now you see transparency here. I'm going to click a alpha button at the bottom of that and make it so that it's black. You could also be working in the grayscale version of this where that wouldn't be an issue. I'm going to make the height a little bit smaller, and I'm going to rotate it to like 1 o'clock on the clock. Okay, now let's make this guy root. So if I select this guy and Control D to duplicate it, and I put that there, then you can see that this guy's a copy of that guy to the extent that it captures even the fact that it has a square, the fact that it's tall and thin, the fact that it's rotated slightly. If I go to this guy and rotate it, you can see he rotates. If I go to this guy and rotate it, you can see that he rotates. Okay, now let me get rid of this guy. Come back over to here, and this time I'm going to right click and say create reference. Now there's a reference. Now what a reference basically is, I'm going to connect it. You can see that it's a copy again. What a reference basically is it's like what you would call in something like Maya an instance, where it's two things that refer to the same basic thing, and if you change it in either place, it's going to change everything. They call them references here, and the reason that they do that is that in object-oriented programming, when you have something which is a category of things, like a class, when you make a particular example of that class, of something from that class, that's called instantiating it, or making an instance of it. And so they actually borrow that terminology here, and you'll see that when you make nodes in the node editor, they're called instances. So they've already used the word instance, so otherwise they maybe would have used it. But at any rate, if I select the guy on the right and turn it, you can see they both turn. And if I select the guy on the left and turn it, they both turn. So let's look at the iterators for a little bit. If I understand this correctly, and if I continue with my idea that control flow rises up from the bottom rather than falling down from the top, then iterators are a lot like a do-while loop, which is to say it falls through at least once, and when it gets to the bottom, it tests the condition and then repeats it as required. So that's sort of analogous to the iterator. Well, I'll show you in a second. Let's see. New substance. I'm starting from scratch. And space bar, FX node, FX map. Select it, Control E to go inside. Now we need a quadrant to generate some sort of a picture, and I'm going to make it a thorn, which is a little glowing dot. Maybe I'll make it a disk, and the size is going to be very small. And the reason we can't see what I'm doing is because it's not the source and it's not the root. So now it's the root. I still can't see it very well because it's on a transparent background and it's white. So I'm going to pop out of this, back up to the FX map, select that, and I'm going to switch from a color mode, which has this alpha channel, which I had been turning off in other examples. I'm just going to switch it to grayscale so that it's another way of seeing. Well, first of all, a lot of what we would be probably doing with masks would be grayscale anyway, so it's good to probably work in grayscale. So here's the pattern. I'm going to make it even smaller. Select it. Okay, that's interesting. Maybe a little bit bigger. And now what I want to do is I want to feed it into an iterator. So click off there, select an iterator, and let's put this into, now this is an optional background slot for the iterator, and this is where the actual input goes for the picture. And then that comes out of here and it can go into, well, let's put it into one of the quadrants of that quad there. Now, if we make this the root, you can see, and that's why I didn't want to make it too small because I knew it was going to end up in a, subdivided by 4. So it's smaller now and a little bit dimmer. But there's a dot, and if we look at the iterator, it's repeating by 1. So let's make it repeat by, I don't know, 6. Now, as described typically in the videos that I've been watching and in the manual, I guess. Actually, I think the manual might not say this, but as described there, the control flows downward. So you start from the root, you work your way downward. It says repeat 6 times, so it does that. And it's a little bit confusing to think that maybe if it really rises from above, how does it know how many times to repeat this by? But what it actually does is it rises up, I think. It hits this. It sees that it needs to iterate 6 times. So that's why it's like a do-while loop. It goes through at least once. And it hits there, and it gets the number of additional times that it needs to iterate. So we can't see it iterating, even though it is, because there's nothing moving these dots around, making them unique. So we need to go back to where the dot is and define it by this, let's say, pattern offset. Go over here, empty function, go to where it's bright there, click on that, edit a function, spacebar, float, and here is, we're going to make a very small number, like under 0.2, because we don't want to kick it too hard, because I want to keep them in a little cluster. So spacebar, random, this will be X, this will be Y. These are random numbers between 0 and whatever number gets fed into their input, so it'll be between 0 and this small number. And then we need vector float 2, which gathers floats and puts them out into a vector 2. So we do that. Now this can be the output node. And you see everything just suddenly kicks over like that and slightly randomizes. Now if we go up to the FX map again, now we have this way of, we have 6 of these, 1, 2, 3, 4, 5, 6. And they're being randomized. We can select this, Control C, and over here, Control V, Control V, Control V, and we can put them. So this, you might think, well, these are copies. So, but the thing is, the random numbers get evaluated uniquely each time. So if I take this one and put it here, you see it's a different little constellation of points. And this one and put it here, and this one and put it here. Now you can see they're all slightly different. Now if I come back up to this upper one and I go to branch offset and I start moving that around until that's about center, and I start moving this around until that's about center, then it's just a little more comfortable to look at. Now, so you can see that when you have these feeding into this like this, that each branch has its own unique random numbers being generated. Now, what's further interesting about this is that if I take all of these and delete them, and I just take this one branch and I feed it up into these 4 slots. Now, normally when you look at a tree, you think, well, if I'm feeding the same output into multiple inputs, then I'm taking the same value and I'm putting it into multiple inputs. But that's not actually what this does. It evaluates everything freshly. So if I were to go like this and like this, you see it's not the same. It's not the same. It's not the same. Now, the other thing is that because it's not the same, because each of these that looks like they're all feeding into a common branch actually get fed into unique branches. And the reason it does that, I think, is because, you know, if you really, you need a way to make this branching manageable, because if you went 4, 5, 6 subdivisions deep and it was all unique branching, it would be extremely wide. I mentioned that earlier in this video. So now let's try to make the iterator have a unique number for each one of these things, so that instead of it being 6 every time, it's a different number. So if we go to the iterator and we go here, now right now it's 6. You can see we can change that number like that, and we can go large or small. But let's make it an empty function, and let's go into that function. Now, what we want is, let's say between, 0 and 10 or 1 and 10. So we'll spacebar float. I'm just going to make random numbers the way I usually do. So here's a number, but this time it's going to be 10. And now random, feed this into here. And so now it's a random number between 0 and 10. And now I'm going to cast it as an integer, 2 integer. So because you think that it probably needs an integer when it's counting how many times to do repetitions. Those are integer numbers. Those are not floating point numbers. So we connect this to this, and now you can see that it's been floating point green. Now it's integer yellow. And let's make this last guy our output node. And so here you can see, let's count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 by coincidence. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. So by coincidence we got 2 5s here, but in general, I'm going to play with different numbers. Trying to see if these two are always having the same 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. I wonder why that is, that these two always seem to have the same number. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Strange. Not sure why that would be, but might just be the luck of the draw. I'm not sure why these two quadrants always seem to have the same number, but it might be a bug, because it can't just be luck, because it seems to be always the case. It's interesting that it works out that way. So that's iterators. Okay, this is the last thing I'm going to do, and it consists of, what I'm going to do is I'm going to have a random number of shapes appear, and I'm going to distribute them around a circle. Now, what's interesting about that is that because the number of shapes is random, you don't know, let's say when you're at shape number 3, how far along the circle it's going to be unless you know how many points are in the entire circle. And as far as I can tell, that number is not given to you. You get which iteration you're on, but I can't seem to locate any place where you get the total number of iterations. I spent a lot of time looking to try to pass information between these nodes using get and set, this way, direction, this direction, and I couldn't seem to get that to work. I don't think it does work. I don't think it's meant to work. So I found some method involving creating this input variable, which is kind of functions like a global variable, and that's what I ended up doing. It feels like it's not really quite the right way to do it, but it works, and it seems to be the accepted method from what I'm finding on the internet. So if you look here, you'll see that I have 1, 2, 3, 4, 5, 6. Now, if I connect this to this guy, then I have 1, 2, 3, 4, 5, 6, 7, 8. If I connect this to this guy, I have 4. And if I do that, I have 4 again. Now, here again, I'm not sure if I'm getting that error where some of these have the same values or not, but I was noticing that when I kind of change this random seed that... And I notice sometimes it goes away, and I think that might be because I'm generating numbers that make the iterations be 0 sometimes. But if I look here, there, every single one of them is different now. 6, 4, 5, and 8. So now what I could do is, notice if I work my way up the chain, which is how I think of things, as I said before, if I set that as root, you can see that I've got more patterns. And if I set this as root, I have even more patterns. Kind of reminds me of early American flags, but it's all different numbers. So the idea is to create regular shapes, like a perfect triangle, perfect hexagon, perfect square, with the points, but have the points be randomly determined. So I'm going to build this from the ground up. But before I do, I'm going to take you on a quick tour of it so that you kind of get a sense of what it's all about. I start out with a shape, a single shape, which is a disk. And I have math in here, which works out how to put it around a circle. And it involves the fact that around a circle, x is equal to r cosine theta, and y is equal to r sine theta, where r is the radius of the circle. Now, if that sounds scary, if it doesn't, maybe it's pretty basic sounding, but if it's not basic, it's surprisingly simple. It's just this. When you have a circle and you want to know what the coordinates of the point are on the circle, if you know the angle, let's say the angle is 30 degrees, the coordinates of the point are cosine of 30, sine of 30. And no matter what the angle is, whether it's 180 or 270 or whatever, if you want to know the x and y coordinates, they are x is cosine, y is sine, and that's all there is to it. And if you don't want to have just a unit circle, if you want to have circles bigger or smaller, then you have to multiply your answer by r, which is why I was saying r cosine theta, r sine theta. And there's one other thing, and that is that I think this software works in radians, not degrees, so you have to do a little bit of a simple conversion. I'll get to that. But basically, I generate a number of iterations randomly, and I pass it through this get integer block to here. And for some reason, it seems to want it to be a float at that point, but I convert it to an integer, and I'm sorry, it's an integer, and I guess I want to do my math in floating point. That's what it is. So I start out as an integer. I put it into float. I divide it by the number that I'm on. The number goes from 0 to n minus 1. And this is a case where that makes the math really easy, because you might think, well, why do they always do that, start at 0? Well, there are different reasons depending on the circumstances. But in this particular circumstance, it turns out that when you're on the, if I can call it the 0th element, then you're at 0 degrees. And you need to go all the way around to not 360, but one less than 360. So it works out that you want to go from 0 to not all the way around to the full number of iterations, but one less than that number. And it makes the math work out really easily without any extra adding or subtracting of ones and things like that. So I take the number that I'm on. I'm not waving the cursor around too much. It drives me nuts when I see tutorials where people do that, but I'm trying not to do it. So I take the number that I'm on and I divide it by the number, the total number, and then I multiply that by 2 pi, and because this produces at this point a percentage of the way around the circle. That percentage of the way around the circle has to be multiplied by 2 pi, which is the full amount around the circle. Then I get cosine, that tells me x, sine, that tells me y. Here's my radius. At this point, it's 0.024, and that gets multiplied by those two things, and then that gets passed out. So if I look at the radius, and if I play with it, and it takes a light touch at this point, I'm going to move it slowly. There we go. See, it's already so big that it's not circles anymore. If I slowly come in, there you go. Now, if I go back to here, and I drop down to, I don't know, this guy, one less, then if I go back into where that radius was, here it is. And there we go. So there you can see that it's kind of neat. And if I come back up here, so that was that's the circle math. Up here is the number of iterations is chosen randomly. So if I go into there, it's just a constant, which is the total number of objects that I want. I happen to be at a floating point number there. This is how many objects that I want. So I can allow more objects, or I can allow fewer objects. You can see that it's changing the points around the circle. I get a random number between 0 and that number, and then I cast that to an integer, which just throws away the fractional point, the decimal point. I think that's where I might be getting some iterations of 0. And I store that in the variable total iterations, which is how I pass that information to the other node. And this is just where they get displayed. Nothing goes on there at all, except it's just a quadrant node. And that same here, nothing goes on here, another quadrant, another quadrant. So these are just, the typical chaining of the quadrants. But I don't start here and then lay down a bunch of these and then start to lay down the math. I think about it very, completely the opposite way around. I lay down a picture. I figure out how to distribute it in a circle. I iterate it, but the iteration needs a random number. But the number of iterations randomly chosen needs to be given down to here so that it knows how far along the circle to put everything. Because if I just say, 5 and it doesn't know that it's out of 5, it doesn't know it's all the way around. Or if it's 5 out of 10, it doesn't know that it's halfway around. So it needs to know that it's not only what number it's on, but out of how many total. That's just nothing but a quadrant thing there, and so is this, and so is this. So that's the point at which, so here again, one more time, in the iterations, I have my quantity. I can change that here. And in the place where I do the circle math, which is just the pattern offset, I have the radius, which if I adjust like this, does that. You can go negative with radius too, it doesn't matter. It just goes the other way through the circle. And now as far as, so if I go up above the FX map to new graph, and I look over here at new graph, this over here, and this took me a while to figure out how to do this and locate this, but over here in the input parameters, which I got by hitting plus and specifying what kind of variable I wanted. This is where I create my variable called total iterations. I'm going to pause at this point, and when I come back, I'm going to actually do the entire thing from the ground up. I'm going to put together what I did in the previous segment. I've already actually done it once, but it froze and it wouldn't let Substance Designer restart. I actually had to reboot my machine, so I don't know, but let's try it again. File, new Substance, okay. Now when I'm here, I put this off until later in the process the last time, and I think that maybe I was referring to a variable that I hadn't defined yet. Maybe that kind of gave Substance a little trouble. So I'm going to define the variable first. Input parameter, hit the plus over here, and then identifier. We're going to call that total iterations. I'm using what they call this camelback notation, where it's lowercase in the beginning and there's a capital letter in the middle of the word. Type, I want an integer. Label, doesn't really matter. Total iterations. Okay, so that should be good. Now come over here, spacebar, FX map. Let's switch it right away to grayscale. Now let's go inside of it, Control E. Back off a little bit. And I need a shape. Double click first. I need a shape or a pattern, and I'll take a disk. I need a size, quite small. That's good enough. I need to define its position, and let's do that really briefly with random positions just to start with. Empty function, go inside, spacebar, float, have that to go to a small number, spacebar, random, Control D, up to one, down to the other, spacebar, vector to vector float 2. That puts that into the format it needs to be. Right click, set output node. Now let's go up here and let's iterate. Put it on this side, and for starters, let's just say the iterations are like, I don't know, 3. Set as root, there you go. So there's the iterations. Now if I go, you can see there's more of them, there's less of them. They're kind of big dots, and they're not being moved very far. Maybe I'll just go back and make them a little smaller. And maybe I'll move them just a little bit farther. There we go. So now back to iterations. Okay, so there you go. You can see that they're randomly being kicked around. Now what I want to do is within iterations, I want to make that be randomly done. So I'm going to say empty function, go in and edit it. Okay, I want to specify how many iterations maximum, maybe something like, oh, I don't know, 8 for starters. And then that needs to be a random number. And then that needs to be stored as an integer. So to integer. See, it goes from green to yellow to integer. And then that needs to get set as a variable. And the variable that we're setting it as is going to be total iterations. That's that global variable we created. Go like that and set as output node. Okay. So now if we come back to FX map, we come back to here and we look in the pattern offset again. Now instead of okay, I was wondering why I wasn't seeing anything. I guess it just was bad luck that it was a low number. Maybe it was 0 because of the way I have my random number set up. That's what I was checking. Maybe if I go back into here and make sure that this number never goes below 1. So I could just say integer, and we'll make the integer 1, and addition. So there's the integer that's being added. That goes to here. Now hopefully I'm not sure why it disappears, but I'm going to leave it as is for the time being. So there's the number that it could possibly be. It's randomly determined up to 9. And we go back to here. Now we come back to this guy. And in pattern offset, we edit that. And here now, what we want to do is, the first thing we want to do is get that value. I think it's an integer. Get integer. There it is. Now if we look here, total iterations. So now we want to promote it to a float. I'm wondering when my cursor is flashing. So to float. There's that. Now what we want to do is we want to take the number that we're on, the iteration that we're on, and divide it by the total number of iterations. So to do that, we need to say get float, and that's the number that we're on. Now, here it is, number. Now, it's odd that, like, I don't know if I mentioned this before, but it's odd that number is shows up in the float list, because it should be an integer, you would think. And if I look into the get list for integers, you can see that that number doesn't show up there. Total iteration shows up, and this other thing shows up there. So for whatever reason, that's odd. So what I want to do is divide. So here's, move this over, and I want to put this through here, and this through here, and that gives me a percentage of the way around the circle. Now what I want to do is I want to say float, and in the float I want 2. I should just click that, 2, and pi. If there's an easier way to get 2 pi, I'd like to know what it is, but in the meantime, multiply 2 pi, and now that wants to get multiplied by the percentage of the way around. So there's a copy of a multiply. There's that times that. That times that. Now this wants to go and we need our sines and cosines. Cosine, that's x. Sine, that's y. So multiplying this by 2 pi converts it into radians. So that's an angle expressed as a percentage of the way around, converted to radians, and then plugged into cosine, plugged into sine. Now what we want to do is we need to multiply it by a radius and get rid of these two and multiply. Control D, we need another multiply. So R cosine, that's the x, and then R sine, that's the y. And now look, it's snapped into a circle. So we go fx map. Now above here we could ask for a quadrant, and let's make that the root, and then let's connect this, 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 and this. And let's just play with this random seed for a little bit. Okay. It's funny how hard it is to get them all different. Wonder why that is. That one looks like they're all different. Let's see, where's the radius? The radius is stored down in this circle math, which is down in here. And edit, here's the radius. And there we go. If we were to look at this one more time, quadrant, up, up. Let me set this as root because it's fun to watch them draw in. up, up. So there you have it. Thanks for watching.